Hello everyone. This is Vinay Kumar from Sri Venkateshwara College of Engineering, Department of CSC Cyber Security. Today I am here to explain about a topic basis and dimensions of the vector space. So coming to introduction of basis and dimensions of a vector space. A vector space is a collection of vectors that satisfy certain properties such as closure under additional and scalar multiplications. Basis and dimensions are fundamental concepts in linear algebra that helps us understand the structure and properties of vector space. In this preparation, we will explore the definitions and properties of basis and dimension in the vector space. This is about the introduction of the basis and dimensions of a vector space. Basis of a vector space definition and properties. The definition and properties is in a vector space. V is a set of vectors that are linear independent or span V. Linear independence means that no vector in the basis can be written as a linear combination of the others. Yeah. Spanning means that every vector in V can be expressed as a linear combination of the basis vectors. So coming to the example of two-dimensional vector space. This is about the 2D plane of a vector space in which consider a vector space V in R2. The vectors 1 0 and 0 1 from the basis of for V because they are linearly independent and span V. Any vector in V can be expressed as a linear combination of 1 0 and 0 1. Dimensions of a vector space. Dimensions of dimensions of a vector space, definition and properties. The dimensions of a vector space V is the it represents the size or the number of degrees of freedom of the vector space. The dimension of V is denoted as dim V. In short, it is called as the dimension of V. Properties of dimension. Key properties of vector space. Dimension. Any two bases of a vector space we have the same number of vectors, hence the same dimension. The dimension of the zero vector space is zero. The dimension of the vector space V is always a non-negative integer. Example of dimension. So linear independence sets relation to basis and dimensions. A set of vectors is linearly independent if no vector in the set can be written as a linear combination of the others. A basis is a linearly independent set that spans the vector space. The size of a basis corresponding to the dimension of the vector space. This is the relation of basis and dimension. This linear independence. Relationship between a base and span. A base is a vector space. The entire vector space. Conversely, any set of vectors that spans a vector space can be reduced to a basis by removing linear independence vector. The span of a set of vectors is the smallest subspace that contains all the vectors in the set. Unique dimensions. The dimensions of a vector space is unique and does not depend on the choice of a basis. Different bases may have different vectors, but they will always have the same number of vectors. This property always allows us to define and compare the dimensions of a vector space. Summary. The main points of this vector space. A basis is a set of linear independent vectors that spans a vector space. The dimensions of a vector space is the number of vectors in any basis of the space. The dimension of a vector space is a unique and important property that helps us understanding its structure. Applications. Partial application of basis and dimensions. Basis and dimensions are fundamental concepts in linear algebra, which is widely used in various fields such as physics, engineering, and computer science engineering. They help us solve systems of linear equations, analyze transformations, and understand the structure of vector space. Applications include image comprehensions, data analysis, and photographics are the basic applications of the dimensions of the vector space. Conclusion. Basis and dimensions provides a powerful framework for understanding and analyzing vector space. They allow us to describe the size and shape of vector space, which is circular in any mathematical and particle applications. By grasping these concepts, we can unlock deeper insights into the structure and behavior of vectors and their spaces. This is about the basis and dimensions of a vector space.